MTE 2021 Virtual Edition will be the catalyst in encouraging innovators and inventors to share and inculcate innovativeness and sustainability in their research. Innovation is not just about making new and better products. It encompasses all aspects of ideas, processes, systems, services, methods, and models.
As large gatherings are no longer encouraged, I'm happy to see that MTE has gone virtual. This will allow more innovators and to promote their innovation and share their ideas with the world.
We look forward to university putting a strong efforts to forge strategic collaboration with industry to generate new sciences, innovations, and commercial entities.
There may come a day in the near future when we have overcome this crisis, but our innovations may be able to assist another country in their fight against the pandemic.
To lift student engagement and attainment in innovation and to support teachers and improve student outcome, innovation and technopreneur mind.
Involving youth at an earlier stage is important, especially as Malaysia is slowly but surely becoming a greying nation. Innovation alone is not sufficient. We must also create an infrastructure for incubation of ideas and transform them into successful ventures.
Enhancing not only in the design but also the delivery of public goods and services for the people. Innovation in government is imperative not only to transform but also to stay ahead of change.
The quick responses to protect its citizens from COVID-19 shows the unity of the nation. Know that your contribution is critical to the transformation of our country.
I'm fully confident that this year's MTE IIA, albeit on a new normal platform and approach, has achieved its desired impacts.
It has been nurturing the innovation culture among scientists, researchers, students and startup founders in order for them to transform their ideas into business ventures.
Innovation, as you know, continues to play the important role in the fight against COVID-19 as governments continue to seek to halt the virus spread in the short term, implement measures to aid economic recovery and build resilience to future social and economic disruptions.
I eagerly look forward to learn more about your work for the COVID-19 response so it can be deployed to help the government manage the pandemic and future emergencies. By embracing innovation, we can certainly reset our approach to combating this war.
This award recognizes and honors innovators, researchers, and businesses for their excellence in innovating during a crisis as well as resilience to look outwards and solve problems that the healthcare system and communities faces.
Knowledge Resources for Science and Technology Excellence Malaysia, or CRIS.my, is a knowledge management portal for research and development, R&D. It is spearheaded by MOSTI to address science and technology challenges faced by the science, technology and innovation STI community. Be a part of CRIS.my to explore the explosion of scientific knowledge and information. CRIS, connecting you to the world of innovation.
Ladies and gentlemen, our next lined up program is a knowledge sharing session. Please enjoy.
Assalamualaikum and hi everyone. I'm glad to share with all of you about my research invention called geophotopaint of geopolymer photocatalyst coating paint. My name is Liana binti Jamaluddin and I also have a team member, Dr. Rafiza Abdul Razak and Professor Muhammad Mustafa Al-Bakri Abdullah. We are from Center of Excellence, Geopolymer and Green Technology, University Malaysia Perlis, UNIMAP Malaysia. So, why we create this geophoto paint? This is because we think we need to contribute to our environment and human. It already 2029, the construction industry is widely developed, but we also need our environment clean without compromise with the development and technology. That's why we came up with the idea on using geopolymer process combined with photocatalyst to produce geophoto paint. The problem is conventional paint is using hazardous and toxic material cause it use organic material, plus we need to solve surface deterioration problem onto the coating. Okay. Another problem is the use of ordinary Portland cement contribute to a rising of greenhouse gas emission. To solve all of this problem, geophoto paint is used as a very good alternative to OPC and also toxic paint, which involve inorganic material and low temperature reaction. Besides, this combination process between geopolymer and photocatalyst reaction mitigate the global environmental pollution problem with development of self-cleaning performance on the geophoto paint. What is geopolymer actually? To simplify the meaning and the mechanism of geopolymer, the geopolymer is an ecologically friendly inorganic material which can be produced at low temperature from industrial waste such as from kaolin, fly ash, GGBS or mining residue. That is the way we turn the waste to something valuable wealthily. Geopolymer incorporated with photoactive material such as zinc oxide and titanium dioxide in the presence of UV and UV visible radiation can oxidize and decompose the surface pollutant on a building or roadway, allowing the products to be subsequently easily removed later by rain. Washing with water because of the hydrophilic surface of the photocatalytic geopolymer with a low water contact angle, allowing it to slide off away all the water and dirt properly. The combination of geopolymer with photocatalyst mechanism illustrated from this figure. How photocatalysts work actually. A photocatalyst coating is a coating that contains photocatalyst as ingredient. Photocatalysis is the complete cycle of converting light energy from sun or an electric light source into a chemical energy that transferred to water vapor to produce active oxygen species to the surface. A photocatalyst coating is energized by the presence of light. The excitation of the photocatalyst causes a number of reactions at the surface of the coating. This light stimulation of the photocatalyst transforms the coated surface, creating air purification and is self-cleaning. So this is how we produce the geophotopaint. First step, we are using metakaolin as inorganic materials combined with alkali activator, which is natrium hydroxide and sodium silicate. After that, zinc oxide as photocatalyst material was added into the geopolymer paste homogeneously. Next, the paste was curing for 24 hours at room temperature. So it's time to coat our geophotopaint on any substrate, including ceramic, concrete, and steel. Listed here is a several geophotopaint performance. First, on the effect of photocatalyst by degradation of methylene blue, show the color absorbed by UV light after 60 minute exposure. That is the grade compared with other organic coating which do not have effect of photocatalyst. Second is geophotopaint is high addition strength between coating and substrate up to 5 megapascal. Another performance is a rapid setting time which is 60 minutes compared with OPC 90 minutes and other paint usually around 4 hours. The viscosity of geophotopaint also relevant with ASTM D7867 which is 100 CPS value equal. I'm very happy to share the benefit using geophotopaint. First, it is a non-toxic and less hazardous. This is the very good benefit to human life and environment. Self-cleaning and maintenance saving. High addition strength between coating and substrate make less surface deterioration and long-lasting coating. Antibacterial effect because it decomposes the cell of bacteria and also water purification by decompose dirt and pollutant that contact on the surface. It can be used into the wide ranges of uses. So this is all the suitable application of geophotopaint including brick, ceramic, tile, bridge, pavement and many more. What you get from this product is self-cleaning properties which is surely reduce the maintenance cost, easy apply, fast setting time, can reapply this coating, good addition bonding between coating and substrate. Our research also has been patented by US patent, Malaysian patent filing and also European patent filing. So thank you very much for listening and I hope all of you get the benefit from this invention.
Hi everyone, Assalamualaikum warahmatullahi wabarakatuh and Salam Sejahtera. I'm Saiful Zamri bin Abdul Rahim from Center of Excellence in Geopolymer and Green Technology, Faculty of Mechanical Engineering Technology, University Malaysia Perlis. I would like to introduce our newly innovated gardening product called Vertical Organic Aquaponic Cultivation Void System in conjunction for Malaysia Technology Expo MTE 2021, which related to Sustainable Development Goal SDG. Do you want to make money from growing plants? Do you want to grow your own food that is free from chemicals? Save your money, lets you enjoy fresh food. So, what is your problem? Dry land, poor quality soil, limited space because of public housing, limited source of water, no time for planting and monitoring, money, or four-season country. Here is your solution. Vertical organic aquaponic cultivation void system. This innovation has been patented at Intellectual Property Corporation of Malaysia in June and March 2021. One cycle of void system is between 21 to 28 days, and the output of vegetables per cycle is between 14.4 kg to 21.6 kg vegetables. These are the cost of void system. These are alternative vegetables for aquaponic cultivation. Okay, now we look on how void system works. We can customize the design based on customer demand. So, if you are interested, please contact me through this email and my phone number. Thank you very much.
Good day, everyone. Today I'll be presenting our invention called a robust lead-free solder joint for harsh environment electronic interconnect applications. I'm Muhammad Arif Anwar Muhammad Saleh, the lead inventor for this invention, and our teammates consists of Dr. Muhammad Izrul Izwan Ramli, Dr. Rita Muhammad Said, Dr. Nur Ainiza Saud, Dr. Flora Swamidin, and also Dr. Dewi Suryani Cik Halim. We are from Electronic Packaging Materials Research Group from the Center of Excellence Geopolymer and Green Technology, CGOG University Malaysia Police. The description of our invention is a robust high-strength green composite solder was invented. A tin-based lead-free solder using nano-reinforcement additions were produced. The high-strength lead-free solder could be used for harsh environment electronic interconnects, such as for power module telecommunication, for aerospace, and also automotive applications. A robust green solder joint, which is considered as lead-free, is needed, especially for harsh environment application, where current available solder joints could not stand at harsh environments. This is an example of where the solder joints are inside an electronic or electrical device. So this is an example of a motherboard of your iPhone. So this is where the lead-free solder joints are. So the lead-free solder joints or the solder joints are made with three main objectives. First is for a conductive path. Secondly is for thermal conductivity, and thirdly is for mechanical support. For the problem statement, the telecommunication networks, aerospace, and automotive components comprise of digital electronics. Like any other computer or sensitive electronic components or equipments, these electronic components are susceptible to damage from mechanical loadings, temperature, and also electrical disturbance. On the other hand, due to the rapid technology advancement, old electronic components normally end up in landfill. Thus, an environment-friendly electronic component following the RoHS legislation, which is the Restriction of Hazardous Substances legislation, is needed. Besides that, we also need to have a robust solder joints in order to eliminate catastrophic failures, especially in the application of aerospace application. For example, of this air crash investigation made for the Airbus A320 from Surabaya to Singapore in December 2014. From the air crash investigation, it was found out that the failure was due to the cracked solder joints. And from detailed investigation, it was identified that the rudder travel limiter unit, which is the RTLU failure, was due to the solder joint crack. So this shows why do we really need a strong or robust lead-free solder joint, especially for this harsh environment, such as for aerospace application, automotive application, and also for telecommunication applications. Following to the Sustainable Development Goals, our inventions are following the SDG number 9, which is Industry, Innovation and Infrastructure, and also SDG number 11, Sustainable Cities and Communities. The reason why is number 9 is since we are producing robust lead-free solder joints, it is for the interconnects, electrical interconnects for various applications. On another hand, is the SDG number 11 is due to the lead-free solder joints that we are producing. So we know that due to the rapid technology, the electronic components normally end up in landfill. So since we are producing these lead-free solder joints, we are able to make sure that we have a sustainable city and also community. The novelties of our invention is, firstly, is its excellent thermal resistance for high power module applications, whereby our solder material can stand up to high temperature. Besides that, the outstanding solder ability and mechanical properties of our solder joints. The invention advantages of our solder material is first, is excellent solder with good wettability. Second is the excellent thermal stability. Thirdly is low production costs. Fourthly is oxidation resistance. And finally is the environmental friendly, since we are producing a lead-free solder material. For the commercial potential, it is a non-hazardous material, solder material. It is recommended to replace the existing tin, silver, copper, or normally known as SAC, and also tin 0.7 copper solder for different solder application. And also could be used for wide range of harsh environmental applications, such as for telecommunication, for aerospace application, and also for automotive applications. This invention is with collaboration with Nihon Superior, based in Osaka, Japan. And this research projects was conducted since 2012. For the patent of our invention, we have patented our invention basically, which is patent granted. First is the solder composition and method of production thereof. And also recently we have also patent filed a system and a method of producing granulated solders. Besides that, in research development, we do also have published several leading impact publications. So we have here, for example, is in 2017, we have published in Scientific Reports. In 2016, we have published in Journal of Electronic Materials. In 2018, we have published in Solid State Phenomena. And we do also published or presented this invention in several leading conferences, such as in the International Conference of Functional Materials and Metallurgy in 2016, and also a conference which led to the publication in the Materials Science Forum in 2016. If you do have any further questions or any interest, you may contact the following contact detail. You may contact us by email to Arif Anwar, ARIFANUAR @unimap.edu.my. Thank you very much for listening.
Hi, Assalamualaikum, and very good day to everyone. My name is Rafiza binti Abdul Razak. I'm from University Malaysia Police. I would like to introduce our product entitled Multipurpose Artificial Aggregate Based Geopolymer Incorporation Palm Oil Boiler Ash, FOBA. As introduction, in concrete, aggregate is required in the production of concrete, and the aggregate is a types of materials that require around 50% to 60% in the production of concrete. Aggregate also used as the aggregate culture for the plant growth. Recycled aggregate or crushed waste concrete is a feasible source of aggregates and an economic reality. Artificial aggregate from waste material also one of the alternative to the conventional stone aggregate and always related to green material due to waste material use. What is geopolymer? Geopolymer has been viewed as a potential, ideal, and green material to replace cement. The recycling of Portland cement-based concrete as recycled aggregate was investigated diffusely, while the reuse of geopolymer was paid little attention. In comparison to LPC concrete, geopolymer 1 is characterized by a low carbon footprint with a high chemical resistance, a low water permeability, and an excellent fire resistance. Rapid consumption of rock resources has brought a big challenge to the sustainable development of concrete industry. The main problem statement related to the high abundance of palm oil waste in Malaysia. Based on Malaysian Palm Oil Council, Malaysia is one of the leading suppliers of palm oil around the world. According to Malaysian Oil Palm Statistic 2020, the production of palm oil in Malaysia is 19.14 million tons, and the production of palm oil will generate a lot of solid waste such as empty fruit branch, fibers, and palm kernel shell. The palm oil waste can be used as generating electricity by burning it into the boiler, and the byproduct obtained is called as a palm oil boiler ash. The other problem statement is related to the depletion of natural resources of aggregate. The new alternative production of aggregate should be investigated to meet the growing demand of aggregate. The method of synthesis of aggregate, especially for lightweight aggregate, consume to high energy due to high sintering temperature used to achieve the lightweight properties. As we can see here, the commercial aggregate such as LECA and sintered fly ash aggregate required high sintering temperature which is above 1000 degrees Celsius. This is led to high energy used during pelletization process that results in higher manufacturing costs. Thus, artificial aggregate-based geopolymer incorporating of palm oil boiler ash is introduced in this research. This is the chemical composition of palm oil boiler ash. It shows that POBA consists high composition of silicon dioxide, aluminum oxides, and calcium oxides, which make it suitable to be used as raw materials of geopolymer. More environmental friendly, which is not using high sintering temperature. The palm oil boiler that has been collected will be grinded and sieved into the powder form to form the palm oil boiler ash. The palm oil boiler ash will be mixed with the alkali activator that consists of sodium hydroxides and also sodium silicates to form the POBA geopolymer paste. Then, the POBA geopolymer paste will be pelletized into the required shape and size to produce the POBA geopolymer aggregates. The POBA geopolymer aggregates then will be hardened in the oven at 80 degrees Celsius for 24 hours. And then the ready sample will be tested for the specific gravity, water absorptions, aggregate impact value, and also aggregate crushing value. And here
At
is the
first,
video shows
palm
the
oil boiler
process
ash
on
is
producing
graded
POBA
into fine powder
geopolymer
form by
aggregates.
using mortar and pestle. Then, plant oil boiler ash is mixed with sodium hydroxide solution and sodium silicate solution until it is mixed well. The geopolymer-based plant oil boiler ash sample is manually made into aggregate size by using hand. After the aggregate is made, the artificial aggregate is poured on the tray and the step is repeated. When the artificial aggregate is made, the geopolymer-based artificial aggregate will be put into the oven at 80 degrees Celsius for 24 hours.
For the finding of this study, as we can see in table 1, it shows the properties of POBA geopolymer aggregates. For the specific gravity, it has been obtained from in the range of 1.3 to 1.6. And the aggregate impact value is in the range from 24 to 29%. And aggregate crushing value is in the range of 25 to 29%. And water absorption is in the range of 20 to 26%. For the specific gravity, as you can see here, it shows that all samples shows the specific gravity which is less than 2.0, which can be considered as the lightweight aggregates. And the aggregate impact value for all samples shows the value of AIV is less than 30%, which shows that the aggregate produced is in a strong aggregate. And the same pattern also shows for aggregate crushing value. The aggregate crushing value shows here the results is below than 30%, which can be considered as a strong aggregate. And for the water absorption, you can see for the all sample shows the water absorption obtained is in the range of 25%, which is still under the limitation. And here is the graph of the aggregate impact value versus water absorption, and also the graph of the aggregate crushing value against the water absorptions. As you can see here, both graph shows a strong correlation between the aggregate impact value or aggregate crushing value against the water absorptions. For the performance of POBA geopolymer aggregates in the lightweight concretes, as you can see here, the density of the lightweight concrete will be in the range of 1,810 kg per meter cube to 1,850 kg per meter cube. And the compressive strength achieved up to 22.5 megapascals for 28 days. And here is the comparable of the lightweight concrete with POBA geopolymer aggregates compared with the American Concrete Institute, which is the guide for the structural lightweight aggregate concrete. As we can see here, the density is almost similar, and the compressive strength for the lightweight concrete with the POBA geopolymer aggregate is higher than the ACI provided. And this is a comparison between the lightweight concrete incorporating of POBA geopolymer aggregates and also the lightweight concrete incorporating with the LECA, which is the commercial lightweight aggregates. And the density result shows that comparable of the density results, which is in the range of 1,800 to 1,900 kg per meter cube. And for the compressive strength, you can see that it is still comparable to the commercial LECA. As a conclusion, specific gravity and water absorption tests for the POBA geopolymer aggregate is in a certain range to be used as lightweight aggregates. Aggregate impact value and also aggregate crushing value for POBA geopolymer aggregate is less than 30%, which is considered as a strong aggregate. Geopolymer-based palm oil body ash POBA aggregate has the potential to be used as lightweight aggregate for lightweight concrete and also for hydroculture for the plants. Thank you for listening, and please contact us if you have any further inquiry to be asked. Thank you very much.